is photolytic decomposition reaction of silver chloride. This is silver chloride AgCl. When we pass a bright light over it, the source of this light could be anything. It could be sunlight, it could be a tube light source, it could be a bulb, it could be anything, torch. When we pass a bright light over the white silver chloride or silver bromide, after some time we will observe that this mixture will turn grayish. It will take some time, but it will turn grayish. After some time you can easily see that this silver chloride had turned grayish. How? The light source which we are using causes photolytic decomposition, causing AgCl to separate and forming a pure silver metal, along with the formation or evolution of chlorine gas, and the mixture turns grayish. This is the reaction of photolytic decomposition. Next reaction is the displacement reaction between iron and copper sulfate. Iron is a silvery or grayish color compound. Copper sulfate is blue color compound. When we take the solution of copper sulfate in water, when we take the solution of copper sulfate in water, this is the blue color copper sulfate solution, and we add iron to it. First we need to make this solution homogeneous. By vigorous shaking we can make this a homogeneous solution. Now this is looking homogeneous solution. Now we will add this iron to the blue color copper sulfate. After some time you will observe that the blue color solution will changes to light green due to the formation of iron sulfate in the solution, and the silver color iron will turn brown, reddish to brownish color due to the formation of copper. This is a displacement reaction. Iron, a more reactive element, displaces less reactive copper from its solution. Hence we observe iron sulfate in the solution and copper deposit on the iron. Observe the solution. The solution is slightly changing its color. Also you will observe that the silver color iron has become brownish in color. If I show you, you will observe that the solution is slightly changing its color, but the main difference is that the iron, which was silver, has become brownish due to the deposition of copper. This is the displacement reaction. The color of the solution has changed and the silver color iron has become brownish due to the deposition of copper. The reaction between copper sulfate and zinc. Copper sulfate again is blue in color. We will add the copper sulfate to the test tube to make it a solution. Add water to it to make a homogeneous solution. We will mix it to make a homogeneous solution. This becomes a blue color copper sulfate solution. Now we will be adding zinc granules to it. Zinc granules again are silver in color. On their addition, we will observe that the solution will become colorless due to the formation of zinc sulfate in the solution, and the zinc granules which we are adding will become brownish. You can easily observe that they are becoming brownish. Why? This happens because zinc metal which we are adding displaces the copper from the copper sulfate solution. So the solution becomes zinc sulfate, and zinc sulfate is colorless. Second, the zinc which displaces copper, zinc metal, and hence the zinc becomes brownish. This is a displacement reaction. Next reaction is the double displacement reaction between sodium sulfate and barium chloride. We will take both these solutions in the test tube. First we will take sodium sulfate in one test tube, and we will take barium chloride in second test tube. We will mix them and we will observe the formation of white PPT. We will observe white PPT here. First we will take sodium sulfate in one of the test tube. Add water to the sodium sulfate. Try to make it a homogeneous solution. This is sodium sulfate. Now we will take barium chloride in the second test tube. We can take more barium chloride in the test tube. I think we have taken more than required test. Now we will add the water to the barium chloride to make it a solution, and now we will mix both these solution. I am adding sodium sulfate to the barium chloride. Now after some time we will observe the formation of a white PPT at the bottom. You can clearly see that the white PPT is forming near the bottom of the test tube. Basically precipitate is generally a insoluble solid that forms near the bottom of a test tube and separates from the solution. You can clearly see that the white PPT is formed below the test tube, and a liquid or a solution is formed above it. This is the white PPT form here is barium sulfate. Actually we have taken sodium sulfate first. We have taken sodium sulfate, we have added it to the barium chloride, double displacement reaction occur. In the bottom we observe barium sulfate form, which is white PPT. At the upper surface we observe the formation of NaCl, sodium chloride. This is the double displacement reaction. We have another double displacement reaction between lead nitrate and potassium iodide. This is lead nitrate and this is potassium iodide. Both are colorless. First we will take lead nitrate to the test tube. This is colorless, so we will take it to the test tube. Okay, so we have taken the lead nitrate to the test tube. Now we will be adding the potassium iodide to the test tube. Lead nitrate is colorless. I am adding potassium iodide using dropper. You will immediately see the formation of yellow PPT. Look, you will immediately see the formation of yellow PPT. How come? How this yellow PPT is formed? Actually, when lead nitrate reacts with the potassium iodide, then there is a formation of lead iodide. Lead nitrate, potassium iodide react, they give lead iodide and potassium nitrate. Yellow color compound formed here is lead iodide. Yellow compound formed below. Below formed compound yellow is lead iodide. The compound formed below is yellow iodide, which is a precipitate, and the above solution form is lead potassium nitrate. Potassium nitrate is white, but because of the lead iodide, the solution is appearing yellowish. But at the bottom here you can see the formation of lead iodide, and above there is a white compound called potassium nitrate. This is a double displacement reaction that leads to the formation of yellow PPT. Actually it is a double displacement reaction, but we have observed a yellow PPT here. So it is a precipitation reaction also. In precipitation reaction we observe the formation of an insoluble precipitate. In precipitation reaction we observe the formation of yellow, we observe the formation of insoluble precipitate. This is a double displacement as well as precipitation reaction.